All right, to wrap things up today, let's take a little closer look at this power rule for integrals, and in particular at this exception. Because here's our power rule, but we said it doesn't work when that power, r, is equal to -1, which I think raises the natural question, what do we do if we need to integrate and that power is -1? Well, the nice thing is that that's only one specific function. If r is -1, that's in fact exactly the situation where we're integrating x to the power of -1, or in other words, 1 over x. And do we know any functions whose derivative is 1 over x? Yeah, absolutely we do. We saw that in Math 1000 as well. So what about x to the -1? Or in other words, the integral of 1 over x. Well, we know, in fact, that it's the natural logarithmic function whose derivative is 1 over x. So it seems like a natural thing to say then that, all right, well, the integral of 1 over x must be the natural log of x plus c. But there's a small problem there. And that's that the domain of the natural log of x and the domain of 1 over x, they aren't the same. 1 over x is defined for all real numbers except x equals 0. The natural log of x isn't defined at 0 either, but nor is it defined for any negative number. And what we ideally want is we want the integrand and the integral to have the exact same domain. So this is true for the natural log of x is defined only for x greater than 0, while 1 over x is defined for all x not equal to 0. So the question becomes then, is there another function which will serve as the integral of 1 over x for the values of x that are in the difference here? In other words, for x less than 0. And while in principle that could be a very different function from the natural log of x, we hope that it isn't, because that's going to really make working with 1 over x, which is a pretty common function, it's going to make that much more complicated than we really want it to be. But observe. But if I've got the derivative of the natural log of -x, well, I can do that by the chain rule. I know that's going to be 1 over -x times the derivative of -x, which is -1. Those negatives will cancel. So that's also equal to 1 over x. And the natural log of -x, well, that's only going to be defined when x is negative, because we need to make sure that that argument of the natural log function is positive. So we could say that the integral of 1 over x is equal to the natural log of x when x is positive, and is equal to the natural log of -x when x is negative. But hang on now. X when x is positive, -x when x is negative. We've seen that before. That's the way we define the absolute value function as a piecewise function. So in fact, we can combine these results. So that tells us that the integral of 1 over x is the natural log of x plus c for x greater than 0, and it's the natural log of -x plus c for x less than 0, or put together, we have our fourth common integral, which is that the integral of 1 over x most simply can be written as the natural log of the absolute value of x plus c. And this function, with the absolute value stuck in, and the integrand, now they are both defined for the exact same values of x. They're both defined everywhere except at x equals 0. So what it does just mean is that when you're working with 1 over x and you're integrating it, you have to remember to include those absolute value bars in the natural logarithm. There's 4 common integrals down, a bunch more to go. That's where we'll pick up in the next lecture. See you then.